Hello everyone, welcome to my YouTube channel, Mr. Data Scientist. I'm really excited to have you here again. If you're following along with this series, you already know that in the last video, we set up a database in our voice assistant project, and we talked about how we store system commands, like application paths, and web commands, like URLs, in two different tables. We also inserted some data into these tables to test our setup. For example, in the web command table, we added URLs for websites like YouTube, Canva, Facebook, and Google. And in the system command table, we added file paths for applications such as Visual Studio Code and OneNote. This database setup is key for enabling our assistant to efficiently handle both system applications and web applications, making the assistant much more powerful and versatile. In today's video, we're going to use this data to perform actions. We're going to open the websites stored in the web command table in the browser, and we'll also launch the applications stored in the system command table directly on our PC. Before we dive into the code, make sure to give this video a thumbs up and subscribe to the channel if you haven't already. Your support really helps me continue making these tutorials. All right, let's jump right into the coding part. As you may remember, in our project we already have a function in the features.py file called openCommand. This function is quite simple. It just takes the voice query, remove the assistant's name, and open the application using a hard-coded command. However, now that we've set up a database to store application paths and URLs, we need to modify this function so that it can interact with our database and retrieve the correct paths from the name column of the database tables. Let me show you the code for this. I've already written the code, so I'm just going to copy and paste the code here to save time. Let's go through this code step by step to understand what's happening. First, we're doing some basic cleanup on the voice command, or the query. When a user says something like, "Hey Sophia, open YouTube," we want to clean that up and focus on just the keyword, which in this case is YouTube. This statement removes the assistant's name, like Sophia, from the query so we don't process it. Here, we remove the word open because it's not needed when we search the database. We also use strip function to remove any extra spaces and lower function to make the query all lowercase. This ensures we match entries in the database regardless of capitalization. Next, we check if the query is not empty. This step is important because if the user didn't say anything after open, we wouldn't want to process an empty query. If it's not empty, we proceed to look for the app or URL. As we are working with a database, we need a cursor object to execute SQL queries. So, we first need to define this cursor variable and initialize the database connection. This can be done by writing this. Now in this, we try to find the file path for the application in our sys command table using a SQL select query. We execute a query that checks if the name column in the sys command table matches the voice command. If a match is found, we grab the corresponding file path. Cursor.fetchAll function retrieves all matching rows. If the results list has any items, it means we found a match. If we find the file path in the table, then this if block will work. First, the speak function is called to announce what the assistant is about to open, like opening OneNote. After that, the os.startFile function launches the application using the file path we retrieved from the database. Now, you might be wondering why I wrote this here. Don't worry, I'll explain it in detail at the end of the video. So make sure to watch until the end. The return statement is used to exit the function early once the application has been successfully opened. It ensures that once the function finds and opens a matching URL, it stops further execution of the function. This prevents the code from proceeding to any subsequent operations that might be unnecessary because the required action, opening the application, has already been completed. Now, if the application isn't found in the sys command table, we proceed to search the web command table, which is where we store URLs for websites. If the voice command matches an entry in the web command table, we use the Webbrowser.open function to open the URL in the default web browser. The Webbrowser module is a built-in Python library specifically designed for this purpose. It provides a simple way to launch a web browser from your Python code. To use the Webbrowser module, you need to import it at the beginning of your code. Here's how you can do that. If the query isn't found in either the system or web command tables, we still attempt to open it with the os.system command, which tries to open whatever the user said directly. Here, we're using a try except block to catch any errors. If there's an issue with opening the command, for example if the file or URL doesn't exist, we catch the exception and let the user know what went wrong. Finally, we have a general try except block around the whole function to handle any unexpected issues, such as database connection errors or other exceptions. This ensures that even if something unexpected happens, the assistant won't crash, and the user will be informed that something went wrong. By adding this database integration and modifying the open command function, we've made our assistant much smarter. Now, instead of hard-coding paths and URLs, it dynamically retrieves the correct information from a database, which makes it easier to scale and manage over time. Alright, now that we've made the necessary changes, let's run the project and test if everything is working correctly.
3, 2, 1, go.
Let's start by giving the command. Open OneNote.
Opening OneNote.
As you can see, OneNote has been successfully opened using the file path we stored in our system command table. This shows that the integration with the database for system applications is functioning as expected. Now, let's move on to testing a web command. I'll try opening a website by saying, Open Canva.
Opening Canva.
You can see that Canva has opened up in the web browser. This demonstrates that our code can successfully fetch the URL from the web command table and open it in the browser using the Webbrowser module. Let's try one more example to be sure. Open YouTube.
Opening YouTube.
And there you go. YouTube has opened just like that. This means the function is handling both system applications and web URLs perfectly. So far, everything seems to be working fine with no errors, which confirms that our implementation is correct. Now, let me explain why I'm using results 00 when retrieving data from the database. To help clarify this, I'll show you a quick test demo. First, let's open the db.py file. Here, we're going to test how the data is returned from the database. To do that, I'll first comment out these lines. Now here, right? Here, we have the app name, and right below it, the same code we used earlier for querying the database. Finally, I've added a simple statement to print the result so we can see exactly what the database is returning. Let's go ahead and run this file. As you can see, the code is returning the file path correctly, but along with the path, it's also returning extra characters like quotes and brackets. This isn't something we want when we use the path to open applications or URLs, as it could cause errors. Now, let's modify the code by adding 0 at the end of our query and run the file again. Notice what happens. We've removed one layer of the brackets, which is a step in the right direction, but there's still one more set of brackets and quotes remaining. To completely clean up the result, we add another 0 like this. Results 0, 0. Now, when we run the file again, you can see that the file path is returned without any quotes or brackets. This is why we use results 0, 0. It extracts the correct path from the returned data, clean and ready to be used in our application without any formatting issues. Alright, that's it for this video. In the next one, we'll dive into adding WhatsApp features to our voice assistant. We'll send messages using WhatsApp, and we'll also create a new table to store mobile numbers. This way, simply by saying a person's name, we can send them a message or call them directly using voice commands. So stay tuned, and as always, don't forget to like, subscribe, and hit the notification bell so you don't miss out on any updates.